So on this sheet, we've got a copy of the periodic table. And the periodic table is one of the most useful tools that a chemist can have. We're going to use this all the time. Now, if you notice, the periodic table that I gave you here is the same periodic table that they will give you for the AP test. This is the one that we're going to use all the time in class because we need to get really familiar and really comfortable with it. So I'm going to mark up some stuff before we start taking notes that'll make it a little bit easier for me once we get started. So I'm starting with boron, and I'm drawing a line underneath it, going down, over one, down, over one. Okay? And then I'm going to go ahead and color in some elements. So I'm going to make boron pink. Actually, I'll probably just outline it. I'm going to make silicon pink and germanium. I'm going to make arsenic pink as well as antimony, tellurium and polonium, and then astatine, and then this one actually has a new name as of I think it was like December 2016, and I don't remember what it is off the top of my head. Either way, so I'm going to mark those up. So we're going to talk about some information I can get from the periodic table. The first thing I can find out is whether an element is a metal, a non-metal, or a metalloid. So metals are good conductors of heat and electricity. They are malleable, which means if I hit them with a hammer, this is the base root of mallet, so they can be hammered into thin sheets. They are ductile, which means they can be pulled into wires. They're lustrous, which means they're shiny, and they are going to lose electrons to form positive ions, which in the last video we said are called cations. One more fun fact about metals. All of our metals, except mercury, are going to be solids at room temperature. Now, if I'm looking at the periodic table, except for hydrogen, everything to the left of those pink elements I just colored, except hydrogen, everything here is a metal. Same thing with these elements at the bottom. These are all metals as well. So as you can tell, about 80+% of our periodic table are metals. They're malleable, they're ductile, they're good conductors, and they're lustrous. Nonmetals are everything that metals aren't. So metals are malleable, they're flexible, they're flexible. These are going to be brittle. Metals are good conductors. Nonmetals are bad conductors. Metals are lustrous, they're shiny. Nonmetals are dull. Metals lose electrons. Nonmetals gain electrons. We said that a positive ion was a cation. Nonmetals form negative ions called anions. Now our anions are going to be on the other side of the periodic table. So they're going to be hydrogen, which I didn't color yet, and everything to the right of those elements I colored in pink. If you want to do a better job of coloring these in later, then you can do so. So these are my nonmetals. I'm going to make those blue. And then the things in the middle that I made pink, these are my metalloids. So a metalloid can't decide whether it wants to be a metal or a nonmetal, so it has properties of both. It can be lustrous and malleable, but a bad conductor. It can be a good conductor, but really brittle. So it can't decide what it wants to be. Okay? So I can figure out if something's a metal, a nonmetal, or a metalloid. I can also find out about families. Families are going to be vertical columns, and everything in a vertical column is going to have similar properties. So it talks about 1A, 2A, 3A. When we talk about A groups, they're these outer groups. Okay? So group 1A is here, except for hydrogen. Hydrogen's weird. So group 1A, lithium, sodium, potassium, rubidium, cesium, francium. These are our alkali metals. Group 1A, these are very, very reactive. So reactive, if I drop them into water, they're going to catch on fire. So reactive that I can't, or they don't exist as pure elements in nature. They're always going to form a compound. They're always going to have a partner. If I buy the pure element from my chemical supplier, I actually have to store it in oil to keep it from reacting because they're so reactive. So they will form a +1 ion, which means they lose 1 electron. So whenever they form an ion, lithium will be +1, sodium will be +1, potassium will be +1. These are always a +1 charge. Oops, sorry, +1 charge. Alkaline earth metals are less reactive than the alkali metals. They do exist as elements in nature. They will form a +2 charge. Now I can either write this as +1 or 2 plus, I can flip it. It doesn't matter what side it's on. So group 2A is here. So this is my alkaline earth metals. They form cations with a +2 charge. Okay. Halogens. What's special to remember about them is they form something called a diatomic molecule. Now what that prefix di means is 2, so they always have to have a buddy. So my halogens are here. And what I mean by diatomic is I'll never have a single fluorine atom by itself. It's going to be F2. Chlorine will be Cl2. Bromine will be Br2. Iodine will be I2. Okay? They aren't the only atoms that are diatomic. I might make myself a note so that I remember. So I might say something like these. That's not a good color. Let's find something else that actually works. Let's try purple. I might say something like these are diatomic. But they're not the only ones, like I said. Oxygen is also diatomic, so is nitrogen. Okay? And there's one more. Hydrogen is also always diatomic. Now these are important to remember because on the AP test, if they give you an element and they just say fluorine, they expect you to know that it's F2. If they say hydrogen, they expect you to know that it's H2. So my halogens are diatomic. They also form a charge of -1. Remember, all of my metals form anions, so they'll have a negative charge. All of my halogens will form a -1 anion. Noble gases are special. Noble gases exist as monatomic atoms, so they don't partner up. Mono or mon is 1, So my noble gases are here. They don't partner up with anybody. They're actually very non-reactive. They don't like to form ions. They don't like to do anything really, okay? So my noble gases have very little chemical reactivity. They can react, but they don't want to, okay? The last thing we want to talk about, on this side at least, is called periods. Periods are the horizontal rows. So remember, this is group 1A, up and down. Period 1 goes side to side. It only contains hydrogen and helium. Period 2, lithium, beryllium, boron, carbon, nitrogen, side to side. Period 3, side to side. So groups or families, up and down, periods, side to side. Now, I would spend a lot of time with the periodic table because everything that we went through very quickly is stuff that you're going to be expected to know and be very, very familiar with.